Hello everyone, welcome to another video on the Metadata Productive channel. In our today's video, we'll be covering the basics of Python function. We'll be looking at their benefits, how to create and even use them effectively. So please drop your comments and questions in the comment section below. And also remember to like and subscribe to my YouTube channel. And do well to share this video to your family, friends, and loved ones that are interested in Python programming, analyzing data, and even analyzing healthcare data. Okay, so without wasting time, let's dive right in.
A function is a block of reusable code that performs a specific task. It helps in restructuring code, improving readability, and avoiding repetition. What are some key points that we should take note of when making use of Python functions? Functions help break down complex problems into simpler tasks. They promote code reusability and maintainability. Python provides built-in functions, and we've actually made use of some of these built-in functions when using our Python programming language. For example, our print function, when we say print 2 plus 2, okay, so this is a Python built-in function, and Python also gives us that ability as users to define our own custom functions, and that's what we'll be looking at today, how we can create our own custom functions. So types of functions, just like what we said, we have the built-in functions, which are the ones that are predefined by Python already, like our print function, length function, max function, etc. We also have our user-defined functions, which are the ones that we can create by ourselves as users, and we also have the anonymous functions, which are called lambda. These lambda functions are also like our user defined function, but the difference is that for this function we don't give it a name. So there are functions that are defined without a name, and they make use of the lambda keyword. So you can create a function in Python using the def keyword. This is the syntax. Def, your function you want to create must always start with this def keyword. This is a prerequisite. Then the next thing you have to add is your function name, then your parenthesis, which is going to hold your parameters if there are any. Okay, next is your function body, what you want your function to run, right? So your function body, and also, which is optional, you can add a return value or not. So this is optional. Then there are some best practices when writing a function, which is like adding your doc string. Okay, so these doc strings contains description about what your function is all about. Or let's say describes the function. So this is the syntax for writing a Python function. So let's go ahead and create a simple Python function. So this, we said, first of all we are going to call the def function, and your name we want to give to this function. So we want to create a simple Python function that greets. Okay, so we're going to call the name of this our function greets. Then it's taking a parameter called name. So let's go ahead and say we want to print and the individual's name. Okay, so it's going to take in this parameter name. So go ahead and run this so that we can now go ahead and call our function. So for you to be able to call your function, what you have to do is to call the name of your function, and if it takes in a parameter, then we can go ahead and add the name. So can I go ahead now and run this? So you see it says hello Ellen. So we just created a simple greet function that takes the name of whosoever and greets that person. So okay, I'll go ahead and show you another example, and this time around we want our function to add two integers together. So let's call this sum num. So we are adding two integers, right? So let's call our parameters x and y. Okay, so we want to print x plus y. So now we're just going to go ahead and call our function, and want to say sum num 5 comma 8. Okay, and if we go ahead and run this, it gives us 13. Okay, so this is just how a function can be easily created and how you can make use of your function. So in functions we have what we call parameters and arguments, and like what I've shown you earlier, at this point when the variable is listed in the function definition, it is called a parameter, but when the values are being passed to the function when calling it, it is called an argument. Okay, so in this point you can see when we're creating our function, we said define greet, and name here in between these parentheses is a parameter. But when we wanted to call our function, after calling the name of our function, we had to pass in that variable which is the name we wanted to call. At this point, this is our argument. Next, we'll be looking at another example. Let's call this the square function. So what this our function is going to do is going to take in a number and to give us the square of that number. Okay, so if you take note of this, I made use of the return statement. The return statement is used to send a value back from the function. So if you want to go ahead and run this, I would have to create a variable that is going to hold our results. So let's say results, and what do we want to call? We want to call our function and square this. So let's say for example we want to check the square of 6, right? So I can now go ahead and print a result. So if I go ahead and run this, you see we got 36. So if you run this without this return statement here, your function is going to return none by default. So let me go ahead and copy this out or cut this out, and if we go ahead and run this without our return statement, we are going to get none in return. So it's either you go ahead and place in these return statements here, okay, and if we run this, we're going to get our answer. If you don't want to use this return statement, then you can make use of the print statement which we've used earlier on. But when using the print statement, you cannot send your value back from the function as a variable. So in functions we have what we call the scopes of variables. So we have local scope and global scope. Local scope are variables defined inside a function that are only accessible within it, while our global scope are variables defined outside any functions and are accessible anywhere in the code. So let's look at what I'm talking about. So let's state our variable and say s is equals to 10. Take note, this variable which we stated, it's outside our function because we've not defined any function, right? So this is called a global variable. Now let's go ahead and write our function and say we want to define, and let me just create this my function. And state s equals to 5. So if you look at this s equals to 5, which is a variable, it's found under this our function which we've created. So this is our local variable. So we can now go ahead and say, okay, print x. From this block of code, if I go ahead and print s, what is going to be printed to me is s equals to 5. Okay, so let me just go ahead and run this, and let's call our function my function. Okay, so let's run this. You see we printed 5, right? But if I go ahead and let me create extra code cells, so if I go ahead and say, okay, I want to print x, okay, we are going to print out our global variable which is 10. Okay, so why did we get that? Because this our value of printing x which we first did, it's under this our function which we've defined. Whenever we call our function, we are going to get this value of x which is 5, because this print statement is under this our function which we created. But also take note that we've earlier created a variable which is s and we equated it to 10. Okay, so if we go ahead and print this s statement outside our function, we are going to get our global variable. The next type of function which we'll be looking at is the lambda function, also known as the anonymous function. A lambda function is a small anonymous function that can take any number of arguments but has only one expression. So this is the syntax for writing a lambda function. So lambda, your argument, and then your expression. So you can see the difference between writing a lambda function and writing a user defined function. So you can see for the user defined function, we have to give our function a name, but for lambda, you don't give the lambda function a name, you just have to call the lambda keyword. So let's take a simple example how we can make use of the lambda function. So if you looked earlier, we created a square function where we got the square of a number, right? So let's recreate this function using lambda. So we can say lambda x here is our argument, right? So it's just like saying num. Let me change this to num. So it's just like saying num when we pass in our parameter into our square function, right? So this is our argument now. And what is the expression we want? We want num. You can say, so we want num times num, right? So we've just created this same block of line of code as a lambda expression using this line of code. So let's go ahead and run this. So before we do that, we want to save this and say square is equals to our block of line of code so that we can print out our answer. And let's use 6 also. So we want to check the square of 6, and if we run this, we are going to get 36, just like when we use the def square function. So what are some best practices when writing your Python function? So first of all, you have to make use of meaningful function names. For example, you can say when we're creating a function that squared a number, we use the name square. So using this title square is just very easy for you to relate to what we're doing at this moment. Another thing is to keep your function short and focus on a single task. So our square function, all it does is to square a number. It's better for you to create a function that perform one task than creating a function that perform multiple tasks. Then we should also make use of docstring. For example, we can add a docstring to our function and say it returns the square of an integer. Okay, so with this piece of information which was written here, anybody that comes across this our square function already knows that this function can only be used with integer, and what does it do? It returns the square of that number. So what are some use cases of functions in data analysis? So we can use function in cleaning our data. For example, we can write functions to remove missing values or to standardize tests. We can also create functions to compute averages, totals, or growth rates. And most importantly, we can use functions for automating tasks. For example, reusable functions to automate repetitive operations like data transformation. So here is a practice exercise that you can go through to practice what we just looked at. But I'll be solving this first question. Write a function that takes a list of numbers and return their sum. So let's go ahead and solve this. So I'm going to create my function and I'm going to call this sum numbers. Okay, so our function is going to hold the parameter which is our numbers, and we want to return the sum of those numbers. So I'll be showing you how to solve this in two ways, and this is the first. So this first one, we are going to be making use of the Python inbuilt sum function. Okay, this is the Python inbuilt sum function, and which is going to be adding all our numbers. So we've created our function now. I can go ahead and run this, and let's create our list. So we have 1, 3, 2 and 6. Okay, so let's call our sum function now to get our results. Okay, so sum numbers, and what does it take? It takes in our list, right? Num list. And we can go ahead and print our results now. So let's go ahead and run this. To see, we got 12. 6 plus 2 plus 3 plus 1, and that's going to give us the value of 12, right? So this is one way we can go ahead and run this. Another method which we can use if we don't want to make use of the Python inbuilt sum function, let me go ahead and write this our line of code. So we're going to call this sum num, and is also going to take in our numbers. This time around, we're going to initiate a local variable called total, and let's call this 0. Okay, because we want to loop through our list in this situation. So we are going to say for num in our numbers, we are going to add every new number in our list to our initial value of 0, which is our total variable. Okay, so we're going to say our new total variable is going to be our num plus our total value. Okay, and when we are done with that, we just want to go ahead and return total. Okay, we just want to go ahead and return our total value. Okay, so we can go ahead and run this, and we can also go ahead and, let's say, copy this. Okay, and if we paste this here, so we are saying this is our new list now. Okay, let me add an additional value of 8 to it. So this is our new list, num list, and so I want to loop through this list and add each value we are going to get in this list to our total value, which is 0. Yes, what it's going to do is going to go through this list. Our first value is 1. It's going to add 1 to this value here of 0. So 0 plus 1 will be the 1, right? And it's going to return 1. It's going to go next, which is the next value is 3. 3 plus 1 is going to be 4, and it's going to save our total value as 4. That's what it's going to do until it gets to the last value of the list, and whatsoever which is our total value, 8 is going to be added to that, and that value, which is our total value, will then be returned to us. So remember, we change this to some num, so we can go ahead and run this now. You can see if I run this, we got 20 as our result. So these are two ways we can use in answering this first practice exercise. So you can go ahead and try and answer these other two questions. Create a function that checks whether a given number is even or odd, and write a lambda function to find the maximum of two numbers. So that is that for today's lesson on our Python function. Don't forget to like, share and subscribe to my channel Medidata Perspective for more content on Python programming. Drop your questions and comments in the comment section below. See you in our next video, and bye for now.